Hello students, welcome to brilliantmaths.com, where every student has an opportunity to excel in math. This is our website. Take advantage of it. There are lots and lots of resources in there for you. Resources for primary and secondary school mathematics. We also have modules that cover secondary school syllabus. Subscribe and you'll be glad you did. Today's lesson is taken from Brilliant Maths Module 4. Get a copy and let's go to class. In this lesson, we want to look at Pythagoras Theorem, finding the length of the hypotenuse. So many of you have heard about Pythagoras Theorem and you wonder, where do we apply it in real life? Go ask the engineers. They will tell you more. Pythagoras Theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides in a right-angled triangle. So that means that if you have a right-angled triangle, triangle ABC, the hypotenuse is the slanted side. It's the longest side of the three sides of the triangle, and it is opposite the right angle. So the theorem states that the square of the length of AB is equal to the sum of the square of the length of AC and the square of the length of BC. For short, the line opposite the angle is labeled with the same alphabet but in lowercase. So here we can call the hypotenuse side C. And then AC is our B and BC is our A. So that we can write the theorem or the formula as C squared is equal to A squared plus B squared, or B squared plus A squared. Example 1. Find the length of PQ. PQ is the slanted side, is a right angle triangle. So PQ is the hypotenuse. And PR is 16 centimeters. And RQ is 12 centimeters. So first, let's see if we remember the formula. PQ squared, which I like to call our R. The line PQ is our lowercase r. The line PR is our lowercase q, because that line is opposite angle Q. And the line QR is our lowercase p. So to reproduce the formula, I would write that R squared is equal to P squared plus Q squared. Just to help you begin to familiarize yourself with how to write the formula. We're finding PQ, so we're supposed to find R squared. P is 12 centimeters. So 12 centimeters squared plus 16 squared will be equal to R squared. Let's take out our calculators. 12 squared, we all know that, is equal to 144 plus 16 squared is equal to 256. So 256 plus 144 would give us 400. So R squared is equal to 400. So to find the value of R, what do? To take away this square, we find the square root of 400. So R is equal to square root of 400. And the square root of 400 is 20. So PQ is equal to 20 centimeters. Pythagoras theorem is actually very interesting. Let's do some more examples. In this next example, we're still finding the length of the hypotenuse. We said that the hypotenuse is opposite the right angle. So always look out for it. Make sure you identify the hypotenuse before you start. We have 1, 2, 3, 4. It's a quadrilateral. And what's the name of that quadrilateral? That's a trapezium. All right? But we have a dotted line here, which gives us a right angle triangle at this portion. And we're told to find the length of x. So we're going to focus on this right angled triangle. The length of the dotted line is equal to the length of the bottom of the rectangle, which is 15 meters. So I'd like to put it there, 15 meters. So now, x squared will be equal to 12 squared plus 15 squared. 12 squared is 144. 15 squared, I'd like to use my calculator. 15 squared is equal to 225. Just wanted to make sure. So 225 plus 144 would give us 369. That is x squared. So x will be equal to the square root of 369. And what would that be? So the square root of 369 is equal to 19.209. So 19.2 centimeters. So the length of x is equal to 19.2 centimeters. In example 3, we have two triangles, two right angle triangles. One is in the other. So we have, this length is 23 meters, and the entire length here is 15 plus 9. So I'd like to split the two triangles and call this triangle A, which is a smaller triangle, which is a part of triangle B. So triangle B is the entire triangle. All right? So the hypotenuse of the first triangle A is x. So x squared is equal to 23 squared plus 15 squared. And 23 squared would give us 529. 15 squared is equal to 225. If you add them together, you'll get 754. So that is x squared. So x will be the square root of 754. So the square root of 754 is equal to 27.459. So to one decimal place, that would give us 27.5 meters. The next thing we need to do is find the length of y. The dimensions of the bigger triangle is 9 plus 15, which is 24 meters, and 23 meters. So y squared is equal to 24 squared plus 23 squared. Following the same process, 24 squared is equal to 576 plus 23 squared is 529. So the total will be 1,105. So the total is 1,105. So y squared is equal to 1,105. So y will be the square root of 1,105, and that will be equal to 33.24. 33.2 meters. So we found the length of x. X is equal to 27.5 meters, and y is equal to 33.2 meters. You can get more examples from Brilliant Maths Module 4. In this example, we want to learn how to find the length of the other two sides. We have already learned how to find the length of the hypotenuse. So we're finding the other two sides different from the hypotenuse. Example 1 here, we have find the length of x. The hypotenuse is the side opposite the right angle. The length has been given, and that's 15 centimeters. And that's our x, and the base is 11 centimeters. From the Pythagoras Theorem, we know that 15 squared is equal to x squared plus 11 squared. But this time we're finding x. So x squared is equal to, we'll take 11 to the other side, 15 squared minus 11 squared. What is 15 squared? 15 squared is equal to 225 minus 11 squared is 121. So 225 minus 121 is equal to 104. So that means that x squared is equal to 104. So x will be equal to the square root of 104. And that will give us 10.198. So approximately 10.2 centimeters. So the length of x is approximately 10.2 centimeters. In the second example, we're to find the length of y. We have also been given the length of the hypotenuse and one of the sides. So 6 squared is equal to 3.6 squared plus x squared. So using the Pythagoras theorem, 6 squared is equal to 3.6 squared plus x squared. And we're finding the value of x. So 6 squared minus 3.6 squared is equal to x squared. So what is x? Let's see. 6 squared is 36. 3.6 squared is equal to 12.96. And that will give us 23.1. So if x squared is equal to 23.1, then x is the square root of 23.1. And that will be 4.806. So x is equal to 4.8. So the length of x is equal to 4.8. In this part of the lesson, we want to find the length of the other sides, continuing from where we stopped. Example 3. Find the length of x and h in the diagram below. We have triangle ABCD. There are two triangles. Triangle ABC is a smaller triangle inside triangle ABD. First, we are finding x. The length of x will be equal to the hypotenuse, which is AC, hypotenuse squared minus AB squared. Let's see how it works. So 45 squared will be equal to 40 squared plus x squared. So x squared is equal to 45 squared minus 40 squared. So x is equal to 45 squared, which is 2025, minus 40 squared, and 40 squared is equal to 1600. The square root of that difference will be the value of x. X will be equal to 20.6 meters. Work that out. Next, we are supposed to find the length of h. But to get the length of h, you have to find the length of BD and subtract the length of x. So let's find the length of BD. I want to use the letters, the alphabet. So AD squared is equal to AB squared plus BD squared. So AD squared is 50. 50 is equal to 40 squared plus BD squared. So our BD squared will be 50 squared minus 40 squared. 50 squared is 2,500 minus 40 squared is 1,600 so 2,500 minus 1,600 is equal to 900. So BD will be the square root of 900, which will be equal to 30. So the length of BD will be 30 meters. What is the length of H? H will then be 30 meters minus x. Therefore, h is equal to 30 meters minus x. And x is 20.6. So the length of h is equal to 9.4 meters. If you subtract 20.6 from 30, you'll get 9.4. For more of these examples, get a copy of Brilliant Maths Module 4. In this part of the lesson, we want to learn how to solve problems involving the use of Pythagoras theorem. Real life problems now. Example, a ladder leans against a vertical wall of height 12 meters. If the foot of the ladder is 5 meters away from the wall, calculate the length of the ladder. I did say before that anytime you have a problem, a word problem, try to read it twice. Read the problem the first time to get a hang of what you're supposed to do. Then read it the second time to identify the operation or know exactly how to work it out. So we'll read it again. A ladder leans against a vertical wall of height 12 meters. So let's try to sketch what we have. So we have a vertical wall, and the wall is 12 meters, right? Then we have a ladder that's leaning against the wall. So let's say that's the ladder leaning against the wall. All right. And then, if the foot of the ladder is 5 meters away from the wall, the foot of the ladder is 5 meters away from the wall. Find or calculate the length of the ladder. So we're finding the hypotenuse, Pythagoras Theorem. How do we find the length of the hypotenuse? So let's call the hypotenuse x. So x squared is equal to 12 squared plus 5 squared. 12 squared is 144 plus 5 squared is 25. If we add them together, that will give us 169. So x squared is equal to 169. So x is the square root of 169, and that will give us 13. So that means that the ladder is 13 meters long. That's very simple. Let's look at another one. Let's look at this example. Two ships leave port A at the same time. One sails due east for 9 kilometers. The other sails due south for 9.5 kilometers. How far apart are the two ships at this point? I'd like us to read the question again so that we will understand. Two ships leave port A. Then let's try to sketch it out. Solution. So that's our port A. All right? So two ships leave port A at the same time. One sails due east. So you must know your direction, your 4 cardinal points. That is sailing due east for 9 kilometers. The other sails due south. Due south comes down for 9.5 kilometers. How far apart are the two ships at this point? This is the point where the first ship is, and this is the point where the second ship is. So how far apart are they? We are finding the hypotenuse. And this is a right angle triangle because that's due east and due south. So let's call that x. So you read the question and try to sketch it out so you know exactly what to do. So our x squared, since x is the hypotenuse, x squared is equal to 9.5 squared plus 9 squared. 9.5 squared plus 9 squared. 9.5 squared is equal to 90.25 and 9 squared is equal to 81. So the sum of both will be equal to 171.25. But x will be the square root. And the square root of 171.25 is 13.08. So x is approximately 13.1 kilometers. So that means that the two ships at that point are approximately 13.1 kilometers apart. Here we want to learn how to find Pythagorean triples or Pythagorean triads. If A, B, and C are three integers such that the sum of the square of two of them equals the square of the third integer, then A, B, and C are called Pythagorean triples or Pythagorean triads. Among the three integers, the highest value is the hypotenuse. It's a very simple test. The following set of integers are Pythagorean triples: 3, 4, 5. Can we prove that mentally? Here we have been told that the integer with the highest value is the hypotenuse. So the hypotenuse here is 5. So it means that 5 squared is equal to 3 squared plus 4 squared. And that is true because 3 squared is 9 and 4 squared is 16. And 9 plus 16 is 25, which is equal to 5 squared. So we have just proven that 3, 4, and 5 are a set of Pythagorean triples. Let's look at this example. Show that 5, 12, 13 are Pythagorean triples. The largest or highest integer is the hypotenuse. So it means that 5 squared plus 12 squared will be 13 squared. All right? 5 squared is 25 plus 12 squared is 144 and 13 squared is 169. So once we can show that the left-hand side is equal to the right-hand side, then we have been able to prove that they are a Pythagorean triple. 25 plus 144 is 169. So the left-hand side is 169, and that is equal to the right-hand side, which is 169. So we have shown that 5, 12, and 13 is a set of Pythagorean triples. For more of this, get a copy of Brilliant Maths Module 4. You'll be glad you did. I hope you enjoyed today's lesson. It was actually taken from Brilliant Maths Module 4. Get a copy. You'll find lots and lots of resources, more examples, and exercises to help you improve. And always remember, maths is fun, and you can do it. My name is Ngozi Orevaoye. See you again soon.